All right, everything is all set up here. Everything is running, heating up, and good to go. We have the viscometer running here. This is a guar slurry I brought home from work. It is currently at 60 RPM, and it's reading around 110 degrees of deflection. I'll stop this and I'll show you if you come around to this side over here. This is how you release the telescoping arms for this thing. And you can see here, you just bring it down until we're buried. Lock it up. This is pretty viscous stuff, so I think at about 300 RPM it's going to max out. Yeah, that's as much as this guy measures. The heat cup has it all warmed up here. We can turn it up a bit more, but this is about as hot as it gets. Well, no, it gets a little bit hotter. You can see the light comes on when it shows that it's heating, but I don't want to heat it up anymore. It's been running for a little bit right now. So I power this unit down. 10 mil retort has been heating up for about 30 minutes now, so we're going to open the hatch and get that set up. So I'll bring this over here. So I just put together some water and some vegetable oil in here, just so that you can see once it boils down that it's separating the solids and the water and the oil. I did have a tool. Where did it go? There it is. Just to tighten this guy up. So we'll stick the cell into the condenser and tighten that up. I'll bring that back over to the retort. Stick it in place, and then we'll attach the 10 mil graduated cylinder to the bottom and let it do its thing. So while that's doing that, I'll bring you over to the high temperature, high pressure filter press. I've got this set to a specific temperature because that's what we would heat our invert up to in the Western Canadian oil field, but you can see when it's at temperature, the light comes on. If you demand more temperature, the light goes off until you reach temperature, at which point it will come back on again. But I don't want to heat it up too much because that cell is empty. So we're just going to dial it back. Up top here, I have one of the pressure regulators on. And if you look at the gauge here, I'll dial back the bleed off. I don't want to pressure it up too much. Like I said, it's empty. I don't want that cell being pressured up, but it's holding pressure. You can hear the retort start to fire off there right now. Water is starting to boil. It happens pretty quick. We come back up here. I'll just dial that back and bleed the pressure off because, like I said, I don't want to pressure that cell up. There are two regulators for that high temperature, high pressure filter press. You can put back pressure on the bottom if you wanted to. I never did, but this isn't the back pressure regulator. I'll stick it on the top just to show you that it holds pressure as well. So if you look at the gauge here, you can see it's starting to take pressure, holding pressure. I don't want to pressure it up, so I'm just going to bleed it off, and then we'll let the pressure go. I pulled the cell out, but it's pretty hot. Actually, I can probably use my wrench and just hold it up just to show you the cell. It's all sealed in there with those 6 set screws. Once it lays in, you can seat it. Well, it's seated itself right there. So it's unseated right now, and then you turn it, drops in, it's seated. And that's that. You come over to the MBT test kit. You can see I have the beaker with water on the heat plate. It's starting to boil. I thought it would be boiling by now, but I haven't turned it quite up to high, so I'll turn it up to high. We'll get back to that in a second. I'll move these pressure regulators over here. So this is the emulsion stability reader. It comes with 2 calibration probes. The first probe is for 610 volts plus or minus 2%. So I'm going to plug that in. 2% of 610 would be what, 12? So we'll see what this reads. Yeah, it's dead on. And then the next one is the high end. The meter only reads up to 2000 volts or 1199 volts. So this one is for 1952 volts plus or minus 2%, which is about what, 38. And we'll see where it gets to. $19.43, so well within parameters. And then if you plug the actual probe in, and I would always clean this out every time I'd use it. This is a well-maintained piece of equipment. You can see it was still reading. Now it's reading the electrical stability of air, which is going to be maxed out at 1999. And that's that. If you get back to the MBT, you can see the heat plate is now actually boiling the water. So I'm just going to dial that back because you don't need that. Let me come back over to the retort. Kind of tough to see all the oil on the bottom. I'll leave it there because it's still condensing, but I put in about 10% vegetable oil on the bottom. And you can kind of see that where the, just above the 1 mil line on the graduated cylinder is. It'll continue to boil down. Anything that's left in here above 9 would mean that there's 10% solids in that solution. So it's easy to calculate solids content and oil water ratio based on that. Okay, so the rest of this Frontier kit has another filter press. I would use this for water-based mud, but it's all set up. It all comes apart. But if you zoom in on the regulator there, you can see that. Dial back the release. It holds pressure as well. It all works as advertised. Well-maintained stuff. Dial back the regulator and bleed the pressure off. And this cell, this twists off. This regulator pulls off the side of the kit, and it can be stored wherever you like. I'll try and remove this without burning myself. You know what, it's still set to low. Maybe I should just turn it to off. Here we go. I'm just gonna follow this tail and unplug this unit so I can put it on the floor. And then lastly, we have the pressure balance. And like I said, this thing shows some wear because I would use this in the field, on drilling rigs, on the mud tanks. So it's seen some stuff, but it's still calibrated and works fine. So I just have some water here. I'll just fill it full of water. You kind of overfill it so that when you put the cap on, it squirts out so you know that you're full, and you can see that it functions properly. There's the squirt. We'll screw the cap on. And then we'll use the plunger to try and get what water we can out of this beaker. And we'll stick this on the pressure balance and pump it so that we know there's no air inside there. Once the stem pops up, you can pull your plunger back, and then we know that we're full. We're kind of over full because a little bit came up there. So the scale measures in specific gravity. It's an American product, as you know, so you can get pounds per gallon, pounds per cubic feet, or on the opposite side of the scale, slightly more metric if it adds specific gravity, or PSI for 1,000 feet, but we go off specific gravity here in Canada. So this should be around 1. This is not distilled water, this is this tap water, so it should be fairly close. So it is balancing a little bit towards the heavier end. The scale is easily calibrated, just a set screw, and you can add in some steel beads or pieces of cut off wire is what I would use. But yeah, that's pretty much it.